All right, our 3.1, solving systems of equations by graphing. Okay, so we're going to have multiple equations, and we're going to find the solution to both of those equations. All right, so there's about 3 situations that typically happen here. Okay, the first one, where we find one solution. Okay, it's going to be a specific point. So let's say we have a coordinate plane here, and we're going to have 2 lines. Okay, I'm going to give you the equations. You draw the lines, and let's say we get, this is one of our lines, this is one of our lines, and where we find the solution is where those 2 lines intersect. Okay, so that's one situation that will happen. Another situation that will happen is a case where we have many solutions. And so in these cases, okay, we got our one line here, and then we're going to have a second line. And in this case, for many solutions, it's going to be the same exact line. Okay, so now, majority of the time, when I give you the equations, it's not going to look exactly the same, but they really are the same equation. Okay, good way to see that is by graphing it, and you'll see that they're the same exact line. Otherwise, you have to manipulate the equation. That's another way of doing it as well. The third situation that we'll have in solving by graphing, we're going to have one line like this, okay, and then we're going to have another line that is parallel. Okay, if you remember the definition of a parallel line, they're never going to meet. Okay, so if we're solving by graphing and we're looking for that intersecting point of 2 lines and they're parallel, they will never meet. Therefore, there is no solution to that system of equations. Okay, so first off, what we're going to do is we're going to check to see if a specific point is a solution to a system of equations. Okay, so for A here, we got the point 1, 4, and we're going to see if it is a solution to the system. So what we need to do is we need to take that point, plug it into both equations, make sure that we get a true statement for both. Okay, in order for it to be a solution to the system, it has to be for both. So plugging it in, we get 1 minus 3 times 4 equals negative 5. So then 1 minus 12 equals negative 5. Negative 11 does not equal negative 5. Therefore, 1, 4 is not a solution. Okay, if we were to plug that into the other one, let's just go ahead and let's do that. Negative 2 times 1 plus 3 times 4 equals 10. Then we get negative 2 plus 12 equals 10, or 10 equals 10. Okay, so this is a case where we get one that's true, one that's false. In those situations, it is not a solution, okay, because it has to be true for both. So let's go ahead and let's check B there. So we got x minus 3y. So negative 5 minus 3 times 0 is equal to that negative 5. Or negative 5 equals negative 5. So we're good there. Okay, that one's good. But we got to check that second one as well. So negative 2 times that negative 5 plus 3 times 0 equals 10. And 10 does equal 10. So we get a true statement for both. Therefore, since we get true statements for both, this 5, 0 is a solution. Okay? So again, it needs to be true for both equations of the system. Now let's go ahead and let's actually find a solution for a system of equations. So what we need to do, okay, is we need to graph both equations. Okay, there we got 2x minus 2y equals negative 8. So again, finding that x-intercept, find that y-intercept. X-intercept, that y-coordinate is 0, y-intercept, the x-coordinate is 0. So finding that x-intercept, 2x equals negative 8, or x is going to equal negative 4. So again, just you're plugging in 0 for y, so it ends up being 2x equals negative 8, or x equals negative 4. And then for the y-intercept, you end up with negative 2y equals negative 8, or y is equal to positive 4. Okay, so we have our 2 points we need to graph that first equation, negative 4, 0, and 0, 4. Now what's important here is that we make sure we draw our lines as carefully as we can. Because again, we're finding that intersecting point, so we want to make sure we get the correct intersecting point. So then for this one, x and y intercept again. We end up getting 2x equals 4, x equals 2, so we get an x-intercept 2, 0. And then for the y-intercept, 2y equals 4, or y is equal to 2. So we get 2, 0, 0, 2. And there we have our 2 points for our line. Okay, and what we're looking for again is that intersecting point, which we get right here, which is negative 1, 3. Okay, so that is our solution, is negative 1, 3. Now we can go ahead and we can check to make sure that this is a solution, just like we did in example 1 there. So 2 times negative 1 minus 2 times 3 equals negative 8. So negative 2 minus 6 equals negative 8, which is true. And then checking the second equation, 2 times negative 1 plus 2 times 3 equals 4. Negative 2 plus 6 equals 4, which is true as well. Okay, so this is our check here, but our solution is that ordered pair of negative 1, 3. Okay, it's the ordered pair that we can plug into both equations and get a true statement. Okay, now tell how many solutions a linear system has. Okay, again, easy way to do this is to just graph both equations. So let's go ahead and let's start with this one. Okay, this would be my blue equation, blue line. Okay, x-intercept, y-intercept. If we look at it, 2x equals 12, so x is going to equal 6. Y-intercept, 4y equals 12, or y is equal to 3. So there's our 2 points that we have, 6, 0, then 0, 3. Moving on to the second equation then, we'll do that one in green. X-intercept, y-intercept, x equals 6, that one's easy. Okay, and then we got 2y equals 6, or y is equal to 3. So we got 6, 0, 0, 3. And what you notice is we got the 2 exact same x and y intercepts, meaning these are the exact same lines. So in that case, this is where we have infinitely many solutions due to it being the same exact line. Those lines are intersecting constantly throughout the whole line. Okay, so moving on to the next one then. So let's do the top one in red here. We got x-intercept, we have a y-intercept. We got y is going to be 0, then we got x is equal to 5. For the y-intercept, negative y equals 5, so y is equal to negative 5. So 5, 0, 0, negative 5. There's our line. And let's do ahead and do this one in purple. So x-intercept, y-intercept. 2x equals 14, or x is equal to 7. Okay, negative 2y equals 14, or y is equal to negative 7. So we got 7, 0, 0, 7, negative 7, sorry. And what you're going to notice is a parallel line. When we have parallel lines again, that is a case where we have no solution. Okay. One way to check this, if you're getting confused, you can always put these equations into slope-intercept form. Okay, so we got x minus y is equal to 5. Okay, subtracting that x over, we get negative y equals negative x plus 5, and then changing the sign for all of those, y is equal to x minus 5. And then our purple equation, okay, so negative 2y equals negative 2x plus 14. Dividing everything by negative 2, we get x minus 7. So what you notice of these two equations now is that we have the same slope but different y-intercepts. Okay, those are the cases where we have parallel lines. Same slope, different intercepts. Okay, so there's two ways to really find that. In that case, there's no solution. All right, so let's do a quick word problem. Okay, so while we're reading this, let's highlight the important information, okay? You plan to work 200 hours this summer, mowing lawns and babysitting. You need to make a total of $1,300. Babysitting pays $6 per hour, and lawn mowing pays $8 per hour. How many hours should you work at each job? Okay, so always look at what the question is. Okay, the actual question is always going to tell you what your variables should be, because that is the first thing we should really be doing, is defining the variables. Okay, so let's make things easy and kind of label our variables so it line up with what the problem is saying. So we're talking about mowing and babysitting, so I'm going to say M and B. Okay, and the question is saying how many hours should we do each of these jobs. So we're going to say hours mowing and hours babysitting. Okay, now that we have our variables defined, we need to come up with a system of equations. Okay, we're planning to work 200 hours. Okay, so and if we're doing two jobs, it's going to be a combination of the hours that we work mowing and the hours that we work babysitting, which is exactly what our variables are. So the number of hours mowing plus the number of hours babysitting should equal that total of 200. Okay. Now the other thing that is given is the total amount of money that we want to make for that summer, and then also the hourly rate. Okay. So when we're looking at it, we're making $6 per hour when we're babysitting, and then $8 per hour when we mow. Okay. So if you think about it, okay, if I mow for 1 hour, I'm making $8. Mow for 2 hours, 16. 3 hours, 24. Okay, we're taking that pay rate times how many hours we work. Okay, so for mowing, 8 times however many hours we mow. Okay, so that's how much money we're going to be making mowing. And then for babysitting, we're going to multiply 6 times the number of hours that we babysit. Now we want to make a total of $1,300. Okay. So now we have a system of equations. Okay, we're not going to worry about solving this one by graphing, because this is a system of equations that would actually be better to solve using one of these other methods that we will learn in later lessons. Okay, so when you're doing your homework now, you're going to do the 3.1 book assignment. Okay, and you've got a bunch of system of equations that you're going to solve by graphing. Okay, and then checking for solutions as well. So again, 3 different possibilities when solving by graphing, where you get many solutions, 1 solution, or no solutions, all depending on the type of lines that are part of the system. So if you have any questions, make sure you're asking, and have a good day.